As we enter the lab, the first instrument we find is the UV vis. Hiding within is one of our fiercest predators. The praying mantis sits guarding its prize, an air-free sample chamber. Once captured in its claws, the mantis's prey is blasted with light, sending it into an excited state. Once the photon feast is over and the samples relax once more, they make a narrow escape from this insatiable predator. Some of the toughest inhabitants of the Freedman Lab scoff at photons or even fire. But the evolutionary arms race has found their weakness: electricity. With temperatures up to 3,000 degrees centigrade, the arc melter subdues even the most refractory metals. Here we have come to the sealing line, where the fundamental elements of life, hydrogen and oxygen, join together to create temperatures in excess of 2,000 degrees centigrade, hot enough to melt quartz with ease. This heat seals everything from delicately prepared offerings to the giant squid, to great quartz tubes filled with metals prepared for a delicate thermal dance. In the far reaches of the laboratory, we find the wild west of glove boxes, California. Like the gold fields of the 19th century, here graduate students search for the perfect crystal. You can find chemistries of every sort competing to stake a claim: framework synthesis, solid-state precursors, coordination complexes, organometallics, and even the occasional organic chemistry. While this might seem like a lawless place, the one thing that is agreed is that between synthesis, crystallography, and air, there isn't enough room in this town for the three of them. What's that sound? That clarion call through the lab space? Is that a graduate student with a megaphone? The voices of a dozen undergrads calling out in unison? Oh, of course, it's coming from Stephen the postdoc. Many otherwise unattributable loud noises in the Freedman Lab emanate from this peculiar inhabitant, whether excited science noises or lamentations of being undercaffeinated. Can you teach an organic chemist about magnetism? Join the Freedman Lab to find out. As we return to the gentle northern reaches of the lab, we find the water box, where strong reducing agents can peacefully cohabitate with water molecules. Here, this symbiotic relationship of proton-coupled electron transfer allows for the synthesis of radicals and spin-containing molecules and frameworks that require a little H2O. But don't let this unlikely alliance confuse you. Molecular oxygen is still strictly excluded from this ecosystem. Welcome to the crystal cavern that is the metals box, home to the Freedman Group's element collection. In this rigorously oxygen and water-free environment where nitrogen excludes all other volatile compounds, elemental metals like barium and bismuth live without fear of oxidizing attack. Here, they are prepared to dance to the rhythms of heat and pressure to give birth to new intermetallic chemistry. In the central region of the lab, we stumble upon the arid sand box. Much like the tardigrades, the chemicals here thrive in this minimalist environment, even when deprived of both water and oxygen. Their resilience is further tested by the scorching temperatures of the hot plates, with the harsh winters in the cold well. But as the name implies, this versatility creates a synthetic playground, where innovations are coaxed from its unusual inhabitants. After a long journey across the H-Wing, we reach the wilds of Alaska, a glove box for only the harshest and most brutal of chemistries at the frontier. In the depths of this chemical winter, you'll find the most coordinating and treacherous of solvents. DMF, DCM, and methanol work diligently to destroy Alaska's catalyst, only to be thwarted by the valiant efforts of the Freedman Lab. Isolated in a deep, dark cave rests a terrifying radioactive being. Marge. Watch her feast. She is the ferocious Muspauer. Don't let her placid exterior fool you. This beast emits gamma radiation and demands tributes of liquid nitrogen. In return, though, she divulges the secrets of the iron centers in moths, molecules, and solid-state materials. Heading to the aquarium, we find one of our most beloved, if temperamental pets, Squidward, the soothsaying squid. Don't be fooled by this monster's magnetic personality. In one fell swoop, it can find the order in your magnetic chaos or condemn you. Encircling its tribute in its tentacular superconductors to read your quantum horoscope, it knows how many unpaired spins lie in your past and, if you maintain time reversal symmetry, your future. Far afield of the native H-wing habitat of the Freedman Lab, we're approaching a place they visit often. During the life cycle of synthesis and characterization, the Freedman Lab makes many daily migrations to this place. They call it IMCIRC, and its own masters will reveal its secrets to you at another time and place. In the far corner of the office, we find the elusive fifth years. Usually, they remain hidden, writing and applying for jobs. Grad students might avoid these aged mentors, though their guidance and expertise is frequently needed. Gifts can prepare them for your questions and make up for your early mistakes. As we approach the final frontier, the den of the matriarch of this peculiar group, a word of warning. She will offer you tea, and you might even find a steaming cup in your hands without realizing you even asked for it.